So, hi everyone. Uh, can you hear me? Okay. So, today I will be discussing assignment 12 for this course. Okay. So, the content will be related to the reactions, reactivity, and bio inorganic chemistry, structures, and coordination equilibrium. Right. So, the first two questions for this session are: first one is regarding the lability of the complexes. Basically, all the complexes in plus two oxidation state. Okay, and you have to identify which will be the correct order. Okay, basically here size of the metals you have to consider. Okay, the larger the size will be of a metal in the complex. Okay, so greater will be the lability, right? And smaller the size, lesser the lability, because that smaller cation will form a strong bond with the ligand, right? So the concept I have told you, just tell me which will be the right option for this one. And second question is the bond breaking between the metal center and the departing ligand is more important in case of interchange associative mechanism, dissociative mechanism, neither interchange nor associative, or not dissociative, and or both. It is interchange associative or dissociative, right? So if you know the answers, please type in the chat box. Okay, I'll wait for 2 minutes. In the first question, just arrange them in order of their size. Okay. Anybody want to answer? Okay, let me explain that. So, as I have told you that ionic radii of the metal ions increases lability of the metal complexes. Okay, because the size of the metal with in the complex will increase, so the bond strength will decrease. So the complex will be more labile, right? And typically, the ions with smaller radii form stronger bonds than ions with larger radii. Okay, so if we arrange the size of these cations, they will be: first one is beryllium, then calcium, and strontium. So the order of lability will also be in the same order, right? So this will be the right answer. Okay, and yeah, so the second question: in the rate limiting step of an interchange associative mechanism is formation of bond between the entering group and the central metal ion. But if the rate determining step is the breaking of a bond, so that will be the dissociative mechanism. Hence, the in case of dissociative mechanism, the bond breaking between the metal center is and the departing ligand is more important, right? Let's say if you have any octahedral complex and it is undergoing the dissociative mechanism. So the strength of this bond, let's say this is X, and this ligand have to be depart. So if the bond strength of this bond is very less, so this X ligand which will be easily departed, right? But in case of associative mechanism, there is nothing about this departing ligand. So we will talk about the incoming ligand that will be forming the bond with the metal. Okay, so the metal center and the departing ligand is more important in the case of dissociative mechanism. B will be the right answer. Clear? Okay. So moving to the next two, that among the following medically important elements you have to select lithium, silicon, gadolinium, both A and C, right? So in the theory part, you have already studied about the medical importance of these trace elements. Okay, and the next one is among the following the electronic configuration that gives kinetically inert octahedral complexes. Okay, so uh, here are the electronic configurations. First one is for D5, D6. Third is also for D6 and D2. Okay, basically D2 is the labile. Okay, so you can easily filter out the last option. And what about the others two? Okay, okay, I'm getting the answer D and C. Okay, anybody else? So lithium compounds, also known as lithium salts, are primarily used as a psychiatric medications. They are primarily used to treat bipolar disorder and treat major depressive disorder. That does not improve uh, the use of antidepressants, right? So in these disorders, it reduces the risk of suicide. Gadolinium based contrast agents help doctors see abnormal tissues in MRI imagings with more details. So they help doctors diagnose inflammation, tumors, and blood clots by providing them with clearer, brighter image from inside the body. Okay, and if I talk about the second one, that is T to the 6 configuration will be kinetically inert because there will be highest loss of CFSE during intermediate formation. You can say 24 DQ, right? So C will be the right answer for the second one, and D will be the right answer for the first. Okay, clear? So moving to the next, first one is for the dissociative ligand substitution reaction of an octahedral metal complex, the coordination number of the intermediate is, right, whether it will be 7, 6, 5, or 4. And the second one is related to bioinorganic chemistry, that is, which among the following biologically available ligands are not macrocyclic, right? So in inorganic chemistry, you study more about porphyrin rings, corine rings, like in vitamin B12, and other are there, but these metals are attached, except porphyrin, they are attached to different amino acid units. Okay, whether it is aspartic acid, glutamic acid, cysteine amino acid, tyrosine amino acid units, depending upon the molecule about which you are talking, right? So just tell me whether any octahedral complex is undergoing the dissociative reaction. So what will be the coordination number of intermediate? Okay. Yeah. So first one is C. Okay. And what about the second one? Since in case of octahedral, if it is dissociating, the coordination number will be minus 1. Okay. That is 6 minus 1 equal to 5. So square pyramidal structure you can have, right? Or you can say trigonal bipyramidal. But the coordination number is 5 only. Okay. And what about the second one? That is porphyrin, it contains 4 pyrrole rings. Okay. It is having a macromolecular ring, right? Yeah. So it's structured like this. One or pyrrole ring is here, one is here, one is here. Okay, and one CH2 units in between, and conjugation of double bonds, and here the metal, right? That can form coordinate bonds. Okay, so this structure is called macrocycle. In corine, you will be getting one carbon less. Okay, that is basically found in vitamin B12, but aspartate is a amino acid units. Okay, so it is not a macrocyclic compound. Okay, so same thing is written here. Dissociative substitution mechanism describes one of the common pathways through which a ligand substitution reaction take place. For example, uh, octahedral complexes dissociative mechanism proceeds through dissociation of a ligand, right? So resulting in 5 coordinated intermediate compound, which is easily attacked by the incoming ligand Y. Okay, clear? Okay, so the next one, here are three statements you have been given. You have to choose the correct statements about associative ligand substitution reactions. Okay, so in associative ligand substitution reaction, intermediate has higher coordination number than both the reactant and the product. Complex with lower coordination number undergoes associative uh, ligand substitution reaction more rapidly, right? And C is the rate of associative ligand substitution reaction depends upon the leaving group, right? And the second is direct electron transfer. You have to identify in which case you will observe the direct electron transfer, whether it will be outer sphere mechanism or inner sphere mechanism. Basically, in an inner sphere mechanism, you need a brazing ligand between the two complexes, but in case of outer sphere, it is not required. So I have given you the answer already. So you just choose the right option and let me know. Okay, so I got the answer. That is, for second it is A, and for first it is B. Okay, so anybody else wants to give answer other than this? So first it is B. In rate of associative ligand substitution reactions, why it will be depending upon the living group? Is it right? Yeah. So let me explain this. Okay, so okay, let me explain this. So in associative ligand substitution reaction, the coordination number of the intermediate form is 7. Uh, you know about the octahedral wedge structure in which the coordination number is 7. Okay, hence has a higher coordination number than both the reactant and product, because in product you will be finally getting the less coordination number. Okay, or you can say the 6 coordination number in case of octahedral. Okay, and complex with lower oxidation number undergoes associative ligand substitution reaction more rapidly, because there will be less steric crowding in the intermediate. Okay, so if you are having a square planar complex, okay, and one ligand is entered and it is attached to the metal atom, so there will be very less steric crowding in the ligand. Okay, so that's why the intermediate that will be formed, it will be more stable or more facile, you can say, right? But in the reaction, the entering ligand approaches the mental center first. Hence rate of associative ligand substitution reaction depends upon the entering group rather than the leaving group. Okay, so yeah. Okay, so here it is written that substitution reaction in case of associative mechanism, it depends upon leaving group. Okay, it does not. It enters it because basically depends upon the entering group. So this will be the incorrect statement, and A and B will be the correct statement for this. Okay, and about the second one, as I have already told you, that direct electron transfer between two metal center will occur in the case of outer sphere mechanism. But because in case of inner sphere mechanism, electron transfer between metal center occur by the ligands share by two metals undergoing oxidation and reduction. But for outer sphere mechanism, no such bridging ligand is required. Okay, because direct electron transfer can take place between the two centers. Clear? Okay. So the next two, the first is related to the twist mechanism. That is, rate the twist mechanism proceeds through which point group? Okay, and the second one is the mechanism for ligand substitution reaction that does not involve any step, leading to formation of a stable intermediate. Okay, associative, dissociative, interchange, and all of the above. Okay, so these two questions you have already studied in classes. Okay, so just identify the right answer and tell me. Okay, Okay, so you studied two types of twist mechanism. One is Byler and other is Taylor. Okay, so one is Byler is having D3H point group with triangular prismatic intermediate. Okay, uh, like this one. Okay, here is metal. Okay, and in this rather twist mechanism, the intermediate is having a C2B point group. Okay, C2B means that is one, if you rotate the intermediate 180 degree, you will be getting the same structure, and V means the vertical axis. So along the vertical axis, if you rotate it, you will be getting the same structure. So it poses this symmetry, that is C2B. Okay, so, the radar twist mechanism proposed for the racemization of octahedral complexes containing three bidentate chelate rings. So, such complexes typically adopt an octahedral molecular geometry in their ground states, in which case they possess helical chirality, right? So, the pathway entails formation of a triangular prismatic intermediate of C2B uh, group symmetry. But in case of the bilar twist, it is having D3H. Okay, and the associative ligand substitution proceeds through 7 coordinated intermediate formation, whereas proceeds through okay. So the mechanism for ligand substitution reaction that does not involve any step, leading to formation of a stable intermediate. Okay, so in octahedral complexes, okay, so if they are undergoing associative mechanism, okay, or dissociative mechanism, so that depends upon the intermediate stability. Okay, if they are undergoing the associative mechanism, they will form the 7 coordinated intermediate, uh, but in case of dissociative mechanism, they will form 5 coordinated complex. But in case of interchange mechanism, the mechanism is similar, but there is no intermediate formed. Okay, so ligand exchange mechanism is similar, but there will be a no intermediate formation. Okay, yeah. So you have to identify the metal ion present in chlorophyll. I have already given here the structure. Okay, so you know magnesium plus two is present in chlorophyll. Yeah, and for transfer of oxygen, which metal couple is important? Here are two metals given in each options. You have to identify which metal and the structures containing these metals are important in oxygen transfer. Okay, and second one is the reaction of this PTCl4 complex, platinum with chloride complex with if I react with two equivalents of ammonia, what it will produce. Okay, so here for your reference, I have given here the trans effect series that will help you in making the product. Yeah, so B and C. Okay, B, zinc and copper, and C, both cis and trans. So just rethink about these options. I think there is no molecule containing zinc which is involving in oxygen transfer. Zinc is redox inactive metal, that is basically in carbonic anhydrase enzyme that facilitate the reaction of carbonic acid formation in the body. Okay, and copper makes structures are hemirathine and homocyanin that are basically involved in the oxygen transfer. But the very much important metal that is involved in the transfer of oxygen that is present in hemoglobin is iron. Okay, so metal couple, which is very important for transfer of oxygen, it is copper and iron. Getting my point? Okay. Okay. So first, uh, check the first one. That is copper and iron. Okay, and second, you are. This is a common reaction, very popular reaction for formation of cisplatin molecule. Okay, so if you know about the trans effect, because here first chlorine will be this chloride will be displaced by ammonia, and thereafter that particular group will be departed. That is due to the which will be the trans to that ligand which is showing more trans effect. Okay, so for your reference I have given here the trans effect series. Okay, so for first one the right answer is this, and the second one if I talk about the mechanism. Okay, since the trans effect of chloride is more than ammonia, so first ammonia ligand will be attached here, right? But in case of the second step, right, so this chloride and this chloride, okay, so the trans effect of chloride will be more, so that's why this ligand will be departed and ammonia incoming ligand will displace here. So you can see they are cis to each other, so cisplatin formation will be there. Okay, so this group will not be departed because this the trans effect of ammonia is less than chloride. Okay, so that's why this group is will be departed and ammonia will take place of it, right? So the resultant product will be the cisplatin. Okay, are you getting my point? So for second one, what will be the right option? It is A. Okay, right. So the next two question for this session, the inner sphere electron transfer reactions requires a first order reactions through direct transfer of electrons with the metallic centers, inert complex with respect to ligand substitution, no involvement of bridging ligand, and formation of bridged bimetallic species. Okay, so the inner sphere reaction, it is proceeds through the formation of the bridged complex. Okay, and our dental enamel is fluorinated apatite. Okay, because it is more stable towards acid attack. Okay, so if you know the answer about the first one, just tell me. Thereafter, I will discuss it. Okay, so I'll wait for 1 minute. Okay, so first is D and second is C. Okay, anybody else? Because I have already given you many hints about this inner sphere and outer sphere. Okay, Okay, so if I talk about the inner sphere electron transfer mechanism, so you just simply consider this reaction. Okay, here are two complexes, and this ligand basically you can consider it the halide. Okay, and basically as the nucleophilicity increases, the dazing tendency is also increasing for this ligand. In most cases it is halides that are basically making the bridge. Okay, so if you see in the products, okay, so here water is replaced by this X, and this water is added to the this one. Okay, so if I talk about the mechanism, this X is forming bridge between the two complexes. Okay, so if X is having a great tendency with, with chromium. Okay, so this reaction will be very fast because here is a competition between chromium and cobalt. Okay, so the reaction will be more fast, and X will be getting attached with the chromium complex, right? And this water molecule is going to the this complex. So basically, this is the mechanism of inner sphere mechanism. Okay, and generally what is the identification? Generally speaking, one complex is inert, one is labile. Okay, and the inert complex generally have a bridging ligand. Okay, so here is some points to remember while identifying the inner transfer mechanism, inner sphere electron transfer. Okay, so in the inner sphere electron transfer there is a formation of bridged bimetallic species. So here you can see this is a bridged, one metal is here, other is here, so one, it is a bridged bimetallic species formation in inner sphere electron transfer reactions. Okay, okay, so the next two, that is the reaction of this complex with NO2 incoming ligand, that is, and followed by ammonia ligand give rise to. Okay, basically here you have to also apply the trans effect. Okay, so accordingly you will be getting the structure, whether it will be in the trans or it will be cis. Okay, so simply first add this ligand and then check which ligand will be showing the more trans effect, and the trans ligand to that ligand you have to depart, and the new incoming ligand you have to attach there at that position. Okay, so just write the reaction and tell me what product you are getting. And the second one is related to base hydrolysis of this complex, is an overall second order reaction, whereas that of this uh, cobalt hexacyano complex is of first order. The rates depend in both cases solely on the concentration of cobalt complex. This may be due to. Okay, so basically base hydrolysis is explained by the two mechanisms. First is SN2, okay, and second one is SN1 CB, that is conjugate base. So basically, the complex which are having ionizable proton, they can undergo into the conjugate base mechanism. Okay, so just identify that, and what will be the reason for this particular property. Okay, right. Okay, so for first it is A. Okay, and what about the second one? Okay, so let me discuss the mechanism of first one. Okay, so here is the complex. Okay, so first it is the entering ligand, that is NO2. Okay, so after that you have to identify the ammonia will be attached at this position or this position or this position. Okay, so in trans effect series the NO2 minus is having a great trans effect. Okay, so that's why this bond will be easily break out and then ammonia ligand will attack here. So here you can see the angle between these two chloride ligands, that is 180 degree, approx 178. So this is the trans platinum Cl2 NO2 complex. Okay, so this one will be the right answer. And what about the second one? As I have indicated that presence of ionizable proton in this complex generally induce this behavior, because at high concentration of hydroxide anion the reaction rate becomes almost independent of OH concentration. Okay, and the reaction appears to be the first order with respect to the complex ion only. Okay, so this observation cannot be explained by a simple SN2 mechanism. Okay, so that's why the SN1 CB mechanism uh, take place. Okay, so this observation can be easily explained by the SN1 CB mechanism. So what they will be there, so this ammonia first it will be converting to the NH2. Okay, because the base will abstract, right, the proton. Okay, so if I write down the mechanism. Okay, so let me write here. So it will be Cl 35 twice plus OH. It will be like this. Okay, and thereafter this chloride ligand will be detached. That will be this one is formed, right, and after that this OH negative will attack here and replace this NH2. Okay, that will be the final product of this reaction. Okay, so this will be the right answer for this one. You can practice more questions and more reactions like this. Okay, so this was all about this assignment 12. Okay, so thank you very much for attending. Okay, hopefully if there will be any revision session, okay, you will be informed accordingly. So if the revision session take place, I will discuss the summary of this course, and I will conduct the session with all the problems uh, that are basically related to the content of the 12 weeks. Okay, collectively, and that will be beneficial for you, right? So if that will be uh, happening, you will be informed by the NPTEL team, right? So for today, that is all over from my side. Thank you for attending the session.